Today's lesson is finding the area of irregular and composite figures. So the first two problems we see are problems in which they give us an irregular figure. Irregular just means that it doesn't look like a rectangle, it's not really a triangle or a trapezoid, not one that we have a formula for. Now this irregular figure is on graph paper, on grid paper. And so when it is on that, what we can do is count the spaces. However, some of the shape is not on a full space, so we'll have to figure out what to do with that. Well, the first thing we're going to want to do is count all the full spaces. So let's go ahead and count all the full ones. So we'll start with this one here. This is definitely a full one, so I'll put a dot there so I know I've counted that. So we'll start with the full spaces, or full ones, and then we have the partials. And our partial ones, we're only going to take a part of those, and we'll talk about that when we get to it. So we've got 1 full, 2, 3, 4, 5, 6, 7, 8, 9. Those are definitely full ones. Oh, this one's 1 here, so that's 10. This is 11. Now these two are almost full. See how this is so close? Go ahead and count that as well. So we'll count that one. So we were at 9, this was 10, 11, that's 12, this is 13. And these are definitely partials. Let's call the partials half. So let's count up our full ones again. Again, we had these 9, and then this is 10, 11, 12, 13. So 13 full ones. Now the partials, let's go ahead and count those. They've got 1 and 2. And let's cut those in half because they're almost a half. So we've got 2 partials and we're taking half of that 2, so that makes 1. So when I add those two numbers together, I get 14. So I would say an approximate. This is an estimate, just an approximate. That's what the little squiggly equal signs represents, just represents an approximate. Approximately 14 square units. So I'll write down units squared. So we do the same thing on this one. Count the fulls and then the partials. And if it's really close to a full, then maybe count that as a full. So we'll say full, and then we have plus our partials. Now again, the partials, what we're doing when we're dealing with these partials is we're cutting those in half. So we're multiplying the partials by 1/2. And so I'll write that over on this side as well. So let's go ahead and count those full ones. So as I count this, I see 1, 2, 3, 4, 5, 6, 7. I'll call this one 8. It's close. It's not quite a full, but we'll call it a full. So that's 8. This is 9, 10, 11, 12. That's the 12. 13, 14. Now this one, definitely not a full. I'm going to count that as one of my partials. So again, I had 8 here, and I had 9, 10, 11, 12, 13, 14. And so the next one would be this one. This would be 15, 16, 17, 18, 19. And then this one's pretty close to a full. I'm going to go ahead and count this one. So that was, what do we say here? We had 14, 15, 16, 17, 18, 19, 20, 21, 22. So I counted 22. Now I could have said this was a partial, but remember, this is just an estimate. I'm calling this one a half, and this is definitely more than half. So if I took off a little bit of this and added it to this, I would pretty much get a full one. So, and this would still be 1/2. So I think 22 full ones is a good approximate. Now let's count the partials. So here I have 1. Let's change the color here. So I have 1, 2, 3, 4, 5, 6, 7 partials. So I got to take half of 7. So when I do that, I get 3.5 plus 22. And when I add those two numbers together, I get 25.5. So I'll go with that. So this is just an approximate. So 25.5 units squared. And again, it's just an approximate because I'm calling this one here a full one, even though it's not. But this one is not half, even though I'm calling it just a partial, even though I'm calling it a half. So it's just an approximate. Key is that the full ones are worth 1. Partials, I just call a half of a space. And then if 2 are almost, would add up to make a full. And then a partial, maybe call that 1 a full and 1 a partial. Well, here are what we call composite figures. These are figures which we can make rectangles out of, triangles, circles, figures that we can find the area using a formula. And that's what you want to do here. Is you want to find different shapes that you can find the area of, like this one here. See, if I cut it right alongside here, I have two rectangles. So all I have to do is figure out what the area of this one is, and I'll call this one number 1, and then this one here, number 2. And so let's do this. We know that the distance from this point to this point is 1. I just need to find this distance. Well, let's go down here. You see how this entire distance is 5. Well, 3 goes from this point to this point. You see how this is 3 feet right here? So that means that 3 plus 2 feet makes the 5 feet. So that must mean this is 3 and this is 2. So that's why this is 2 feet here. So let's find the area of figure 1. And so I go 2 times by 1, and that gives me 2 square feet. Well, now let's find the area of figure 2. Well, this one is 4 by 5. So plus 4 times by 5, which makes 20 square feet. So when I add those together, I get 22 square feet. And that would be the area. Well, taking a look at our next one here, do the same sort of thing. Let's cut this into different figures. So now we see a rectangle here. And if I go ahead and cut it right here, I've got another rectangle, small one here, and another one right here. So let's call this one number 1, and number 2, and number 3. Those are my 3 different rectangles. So I'm trying to find the area of rectangle 1, and then add it to rectangle 2, and then add it to rectangle 3. So let's go ahead and take a look at our sides here. Rectangle 1, I know this is 3, and this is 6, so that's given to me. 3 times by 6, that makes 18. These are meters squared. So now let's find area 2. Well, I know this is 12, but I don't know this length. See, the entire length is 8. So we need to go over and look for the ones that are parallel to this. So I go over to this one here, and you see how this is 3? Well, that's what I need to take away from 8. You see, this distance from this point to this point is 3. But I don't want that distance. I want to take that away. I just want this distance from here to here. So let's go ahead and take 3 away from 8. So this distance is 8 minus 3, which is 5. So it's 5 meters. And so that's what I'm going to multiply by. 5 times by 12. And that gives me 60. So 60 meters squared there. Now, we've got this last little bit here. So this is rectangle 3, and I want the distance. I know this is 2, but I want the distance here. Well, I go right over here, and this is 3. And this would also be 3 as well. So 3 is not only this side, but also this side here. So I'm going to go plus 2 times by 3. So when I go ahead and multiply those numbers, I get 6 meters squared. So I'm adding up these numbers now. I'll start with these two. That gives me 78, and then plus the 6 gives me 84. So 84 meters squared is my answer. Well, our next figure here, you see how this little one, this little triangle here, I'm going to call number 1, and the rectangle I'm going to call number 2. So I need to find the area of the triangle and add it to the area of the rectangle. Now, what we'll need is the distance from here to here. This is the base of that triangle. The height is 4, I know that, but the base, well, let's go over to what we know. So look at the sides that are going the same direction. Like, for instance, this one down below is 18. That means the entire length of that rectangle is 18. Well, this is 6, and this is 6. That adds to make 12. So if I did 12 minus 6, that gives me 6. So that means this distance right here is 6. So I'm going to go 6 times by 4 divided by 2, or times by 1/2, because that's the formula. Area equals 1/2 base times height. So if I multiply these two, I get 24 times by 1/2 gives me 12. So I have 12 feet squared. So that's just the triangle. Now we do the rectangle. Well, the rectangle is 9 by 18. So 9 times by 18. So we multiply those two numbers, and that gives me 72. And carry a 7. 9 and 1 make 9, plus 7 makes 16. So let's go ahead and put the plus sign down a little bit lower there and add those two numbers together. So I've got 162 square feet plus 12 square feet. So when I add those two numbers together, I end up with 174 square feet. Well, looking at the next one, looks very similar. The difference is that instead of a triangle, now we have a circle. And it's not even a full circle. It's just a portion of a circle on top. So we'll call this one number 1, this one number 2. So we have the same sort of setup as we had before. So let's find the area of the circle. But remember, it's not a full circle. It's only a half of a circle. So I'm going to divide it by 2. So we first need to find the radius. Well, it's the same as the other problem. The difference is that this is a circle rather than a triangle. So I know this is 6, the entire distance down below is 18. So it's the same thing. 6 plus 6 makes the 12, and then I am going to take 6 away from that, because 6 plus 6 plus 6 makes 18. So again, this is 6. I know this has to be 6, and this is already 6, and those numbers add to make that 18, which is the length down below. So I'm going to go with the radius, though, not the diameter. So the radius is only 3. So I'm cutting that in half. So it's 3 squared times by pi. All right, so that makes 9 divided by 2 makes 9 halves pi. Okay, so that's the first part. Now plus the second part, which is this rectangle. Now, the rectangle is 8 by 18 this time. It's 8 times by 18. And when I multiply those, I get 64. 6 and 8 make 14. So now I have to multiply the 9 halves, which is just 4.5. So 4.5 times by 3.14 gives me this 14.13. And this is feet squared plus 144. When I add those two numbers together, I still have that 13 hundredths. And it looks like I don't need to round it, so I'll just leave it like that. And then I add this, I get 18. And then I have 1 and 4 make 5. And 1. And this is feet squared. So there is my answer. Let's take a look at our last problem here. It's one in which we have a rectangle and a circle. But just as before, the circle is not a full circle. It's only a half of a circle. So what we need to do is find the radius. Now notice that the distance from here to here is going to be 10, because I look down and I see the distance down below is 10. So that means this is 5. The radius is 5. So I'm going to find the area of the circle first, and then I'm going to add the rectangle's area. So the area of the circle is 1/2, because it's half of a circle, times by 5 squared times by pi. So that makes 25 divided by 2 times by pi, plus the area of the rectangle. Well, the rectangle is 15 times 10. This is just base times height. So when I multiply those, I get 150. So the hard work is just that 25 divided by 2, and then times by 3.14. And so when I multiply those, I get this large decimal, and it ends up being about, let's say, messed up on my multiplication. Yeah, at first I had around 3, and I knew that wasn't right, because it's 25 divided by 2 is 12.5 times by pi. It's got to be in the close to 40, and when I checked it again, it was 39.25, plus the 150. So when I add those two numbers together, I end up with 189 and 25 hundredths feet squared. So those are the types of problems you'll see on tonight's homework. Good luck.